Thanks for joining. I'm Gary Angel, CEO of Digital Mortar, and I'm going to be talking about machine learning and store optimization, walking you through a recent bit of work we did with our partner, DXI. For so many years, the in-store journey has essentially been a black box. You know what you sold. These days, you usually know how many shoppers came in the door. But what happened in between? It's a mystery. At Digital Mortar, we solve that mystery. We track the shopper journey end to end, and then help you analyze and report on those shoppers to optimize the store. But you can do more than report on that data. Advanced analytics can help you use that data to find optimal paths in the store and parts of the store and journey that aren't working very well. There's a lot of different ways to do that, but one of the best is to let the machine do the work for you. Our partner, DXI, has a suite of machine learning, that's ML, tools that can solve difficult analytic problems. In this collaborative analysis, you'll see how we sourced data, cleaned it, processed it, and then drove recommendations based on the findings to help optimize the store. The basic problem we wanted to solve for our athletic apparel store was to break down thousands of complex shopper journeys and figure out which types of journey drove to a sale and which didn't. This real-time journey map of a location gives you a sense of how crazy complicated this data can be. If you've ever done analysis, you know that a big chunk of the work is data preparation. Our raw shopper journey data looks like this. It's a series of shopper locations. See those X grid and Y grid columns? Those get mapped to the actual store layout. Knowing what was there in the store, that's critical to understanding the shopper journey. For many stores, associates are a huge part of what drives conversion and success. Our system collects associate location data and matches it to the shopper data to track interactions. Those interactions become part of the data sourcing too. Finally, we look to see if shoppers went to the cash wrap and checked out. That's our success metric, and it's critical to have for most ML techniques. After this basic data prep, we aggregate the journey into a single row per visitor that tracks every place a shopper spent time. Again, there are other ways to do this, but this is the easiest way to build an ML-ready record for analysis. Then the data goes to DXI, and they run it. DXI uses an ensemble approach to ML, meaning they process the data against a number of different machine learning algorithms. Each algorithm is a different way of analyzing the data, and then they look for consistently important or successful data patterns across many different ML techniques. That usually indicates something real. So let's take a look. The single poorest performing section wasn't picked by a single machine learning algorithm as important in driving conversion. Yet it occupies a fairly central, store-forward position. Overlaying store geography with performance was a constant theme in this analysis, and this was a case where a decent position was returning very poor results. On the other hand, shoppers who took a right racetrack pattern through the store, that's a common browsing behavior, performed quite well. This was one of the strongest performing patterns in the DXI findings, and it means our store is well optimized for browsers. For this store, casual shoes was critical to overall store performance. It was picked as important by every algorithm, and it had the largest optimal time value, more is better, of any section in the store. Sure, shoes is going to be that way, but casual outperformed running shoes on that same measure. Some DXI algorithms picked this section as important, others didn't. But it was striking that this was a rare area where more time didn't equate to success. And given its strategic location next to the cash wrap, we think it's underperforming. Space next to the cash wrap is super valuable, and it needs to be maximized. One open question was whether associates were pestering shoppers. You really need voice of customer research to answer for sure, but the DXI analysis suggested that at least in terms of conversion, more really is better. Even at 4 or 5 interactions, conversion rates were still increasing. Hey, in days past, individual shopkeepers paid attention to how shoppers navigated the store. They watched you enter and move around the store. They saw where you engaged, where you tried merchandise, what you bought. and they used that information to create a mental model of what worked and what didn't. To this day, we rely on store managers to keep eyeballs on the store and drive those local optimizations. But at today's retail scale, that's a lot to ask. No matter how good your store managers are, they can't watch everyone, and they don't always have the leisure to reflect on what that behavior might mean, nor do they have the luxury of comparing their store to other locations, other cities, and other banners. Machine learning doesn't replace your store manager. It just puts a new set of eyes on the data and lets you take advantage of that data at scale. The machine can remember every shopper from every day for months at a time. And in this project, we were able to apply a machine learning platform originally designed for e-commerce directly to data from our DM1 platform. The combination of DM1 shopper measurement and reporting with advanced machine learning from DXI is a powerful new tool for store optimization. And if you're looking to get started with store measurement, give us a call or drop us a line at info@digitalmortar.com. And of course, you can check out our website, www.digitalmortar.com. Thanks for listening.